Okay, I've finished the build for version 1 of Otto Pico wheels. So I'm just going to show you what's at the base of the body and what I've put in and what I've had to add to the Kitronik board for the Pico. Okay, so first things first, the N20 motors here. Okay, so these are two 300 RPM 6 volt N20 motors. I've just attached these, I'll show you this a bit later, to the wheels designed by Jason for his Otto wheels. So basically this is the body. I've just added a container really for the N20 motors so they don't move around inside when things get going. Okay, so these are just going to be connected up to the Kitronik board, which I'll show you in a minute. Before I get to that, this little thing over here, don't worry about that too much, but this is to drive the buzzer so that it's a bit louder. Okay, so I'm taking the signal from the board, obviously at 3.3 volts, but I'm driving the buzzer using 5 volts. So that is what this the little transistor and the resistor are doing in here. Okay, so that's that part. Now, what I've had to add on the bottom of the Kitronik board are header pins. Okay, so these aren't on here. Okay, let me just take this back. Okay, so you can break out the board underneath the Pico. Okay, it does mean that this sits down below the board itself, and I'll show you the shelf in a second how I've accommodated this, but it means I can break out all of these pins. These are all available to me. These red ones are all at 3.3 volts. I've got plenty of grounds in here. So the two connectors here you can see are for the ultrasonic sensor, and this is the ground and the pin for the buzzer. Okay, so that connects to my little circuit down here just to make it louder. Okay, so that's the bottom of the board. If I look at the top of the board now, not much going on really. The connections for the motors, I've got 4 motor points, so I've connected them to motor 1 and motor 4 simply because they're on the left and the right. You can see I've actually taken the 5 volts from the supply to the buzzer. The ground of the buzzer is actually going to the board underneath. Okay, so oops, that's disappeared. Okay, so these are the 4 motors. Over here actually are the 8 servos. Okay, so they can be used in other things. And there's the Pico sitting on the top. So the board comes with these female headers. Just plug the thing in. You have to solder the male headers onto the board itself. Actually, you can mount this. It didn't work with this board. I did have to hard solder these. Okay, so that's that. So how does it all fit in? Well, I'm going to put the board on this shelf here. Okay, so this shelf actually goes this way round, so that will slot in. The motor cables and the buzzer cable will just fit nicely in here, and this cutout is for the pins that you saw underneath the Kitronik board. Okay, so they sit under there. Now I'm actually using DuPont leads with the smaller heads. Okay, you can get ones with slightly longer heads, they're about 2 millimeters longer. They fit as well, but this makes it nice and neat. I don't bend the wires too much, and it means that on the shelf itself I can make a smaller spacer here. Okay, and then the Pico sits nicely in there when I put the head on. Okay, so that's the first stage of there. What I'll do is in the next part I'll stop the video. I'll pop the shelf in and pop the head on, and then show you the outside of the bot. This is the Kitronik board now mounted on the shelf. Okay, so everything is screwed in. What I haven't done yet is punch a hole through the side of the body so that I've got access to the Pico. I'll do that later. At the moment, this is just prototyping. I was just testing things out when things need to be positioned. You can see it's all very neat in there. Plenty of scope for more connections to the pins underneath the board itself. So plenty that can go on in there. Yes, and this is the back of the buzzer. I've just hot glued it so there's no risk of any shorting in here when I'm messing around with things. Okay, so the connections, yes, this is powered up now however you wish to power it. I don't have a problem with these batteries. This has been working for a couple of days now with me playing around with things, so I'm just going to leave it in. You do need to make sure, of course, with the battery being mounted in the head, that whatever you put in, it's nice and secure. Okay, you don't want it floating around. So whatever you put in, either something like this with a better battery, a LiPo, whatever, then secure it to the head itself. Now, I actually did that by just when I printed this, popping in 4 points for this particular battery module. Now, I've also hardwired, I might do this with all of my Ottos actually, I've hardwired the eyes in. You know, they're always going to be there. They're pretty much always going to be used. Now, of course, this is a 3.3 volts board, and this is a 5 volt module. So I've just basically tapped into the 5 volts here, and you can see this is powering up the board itself. Okay, which then in turn powers up the Pico. There's an on-off switch in here. Okay, and of course there's an on-off switch in here. Now you would almost certainly, I think what I would do in future is put a 5 volt rail in with the power switch there before making any other connections. So somewhere at the back here, there's plenty of room in here for a rail, so I can then, for any 5 volt modules, I can use that rail taken from the battery, whatever battery I've got in here. So that's what I'm planning in the future for Pico projects, so that I've got options. Of course, you saw underneath the Kitronik board the 3 volt pins, 3.3 volt pins, and then I can also give myself the option of having 5 volt pins straight from the battery over here. Okay, if I need to, I mean, of course I could use an LLC. I've got some nice small ones, you know, 8 channel bidirectional. That would be another option, and if I went down that route, I would pop it underneath the shelf in this particular bot. So yeah, so that's at this stage. Okay, so let's just pop the head on. Okay, so that's the front. It should fit nicely. Okay, just jiggle that. Okay, so let's tilt the camera slightly. Okay, so this is the typical wheels. Okay, so the really nice round wheel with an O-ring. So this is a 56mm wheel, a 50mm O-ring, nice and tightly in there. So I designed a coupling shaft here, which just fits onto the D shaft of the N20. You can see in there. Okay, made that black so it looks nice. Okay, and there's the buzzer. So the buzzer is Otto's nose. So rather than the sound coming out of his backside, we have enough politicians in this country where that happens. The sound is going to come from the front of Otto, and this is nice and loud now that I've put that little. Now I'm driving this with the 5 volts rather than 3.3. Okay. Other than that, it's the standard caster that Jason designed. So I don't know if this was the first or last one. I know there's one that goes underneath with the ball bearing. I quite like this one. I don't mind either way. Now you can see I've filled in all the nano holes. I would need to recreate the hole that I need to recharge the battery module, and the hole that I need to then, we'd be back here, to code the Pico would go somewhere. It's about here. Okay, just beside. You can see that part there. Okay, so that's the final build. Now in the next video I'll talk you through the code, and then the last part I'll just demonstrate the fact that it actually works. Okay, I know this is going to be different for all of you, but this is the code that lives or is on the Pico inside Otto. So you can see here I'm using MicroPython. This is really the best platform for the Raspberry Pi. It was developed by Raspberry Pi Foundation, and it's for their Linux-based machines. If you use CircuitPython, I tried it. There's a bit of baggage that goes with it. I just basically reverted back to MicroPython. I'm very comfortable with this. I used Python years ago with the original Raspberry Pi. So there are 4 programs that I have on here. Now the main program is the one that's when you turn on Otto, it will run the main Python code. So this is going to be the one where essentially it will be the one that you would code from Blockly and then uploads to Otto. So whatever you put in main Pi is going to run when you turn everything on. Okay, now main Pi is going to rely on other Python files. So these would be equivalent to the header files and the sort of the C++ files that you would have for the Arduino. I don't have too many. I'm running a very, very simple program where Otto with the Pico just goes forwards. If it sees an object, it stops, goes uh-oh, reverses, turns, and then carries on going forwards and then loops. Okay, so that is basically the main code that you have here. So this is going to be the one that's running. So this is effectively the equivalent of the void loop that we have. And you can see that what I do is I import, now the dependencies, I probably have been a bit lazy with this, but I need to import the Pico Robotics. This is the board program, and UTime is the timing that we have on the Pico. So if I go to Pico Robotics, so this is what's controlling the board. So this is I2C, and it basically just sets up all the addresses for me. And there's some very basic code for servos. So the 8 servos and the 4 motors. So all of that's done there for me. Didn't have to do anything, just downloaded this from Kitronik. So what else do I have on here? Okay, so yeah, the sounds. Okay, well, I just stole these directly from Otto. Partly Otto and partly Python code. So just to keep things, remove as many underscores as possible. They set up the tones. You can see this in an array like this. All of them. And then what I did was, after a little bit of messing around, trying to remember how to do Python, set up the tones that you have in the Otto code and the bend tones. So all of this works nicely now. It's exactly what you have with all of these steps going up or down in proportion. And then, okay, be quiet is just a legacy of the code that I was originally using. And then you've got all of the Otto tones that were coded or are coded in Otto 9, I think it is. So this will be sounds 9 file that I've simply moved over, including the farts, which aren't very good. Okay, so all of that's there, and I can call on any of those. I generally import the whole lot. I'm actually only using one of them. I can't remember which one. I think it's uh-oh or uh-oh2. So I could actually just import that particular function from this if I wanted to, just to save memory, but I've got tons of memory. Okay, so the ultrasonics distance. So actually, I don't need to import the Otto sounds here. This was just when I was testing things out for the ultrasound. So this is the ultrasound code. That's all you need. So it basically just runs this and then sends back the distance, which in the main program, I run the ultrasound from that Python file. Okay, you can see here I've imported everything. I just run that, check the distance. If it's less than 15 centimeters, turn the motors off, and then reverse, I think reverse and turn, and then off it goes again, okay, until it meets another object. So that's it. So that's all you need to do. Coding is very, very straightforward. You can see here, this is all connected up. You stop the program, and then when you want to load any, you can load any particular one. You just load using the run. So I could load the ultrasound. You can see here I've commented bits out. So when I was testing this, I just put these back in and just run this particular code. But of course, when I turn it back on, this will not be in memory, or rather it will be in memory, but it won't be run. It'll be the main Python code that's run. Okay, so it will then revert back to whatever code I've left in main Python. And I can remove that file, and then of course Otto will just remain dead, as it were. Okay, so that's it. Very, very straightforward. At some point I will be porting this out to CircuitPython. Not yet, but I'm very conscious that CircuitPython are actually supporting all of the Adafruit, obviously, because they write it, all of the Adafruit modules, and they're deprecating on MicroPython. So it could be a problem running things like OLEDs in the future without the legacy code, but I'm sure we can get our heads around that at some point. And there is Blockly code out there for this, so it can be done, but that may take some time. Okay, so this is the acid test. I'm going to demonstrate that everything that I've shown you works, and that I am indeed running a Pico. There it is inside. It's not me cheating. And this is a genuine Otto. You can see it's the Otto size. This is Otto wheels. Okay, so all the features. So let's put him through his paces. I'm going to have to chase him around the floor a little bit. Okay. Let's pop him together and send him on his way. Okay, so you get the general idea. He's just going to keep doing that as long as he can. But you can see the sound coming from the buzzer at the front is fantastic. As I said, this is still a prototype. I haven't put any kind of switches or on-off switches on him. All running very nicely. Now the next thing I want to do with Otto, of course, is put the Bluetooth in. It seems very dumb with an RP2040. You really want to get one like the Nano, which has got this all on board. But I'll do that anyway, just to show you and produce the code, tidy up perhaps the Python sounds slightly, and maybe do a few more sounds and have this run using the MIT app. So we have an app specifically for Otto Pico wheels, and then, well, we'll see where you guys want to take this. But yeah, really enjoyed working with an RPI again. I do like them. Not ruling out the ESP32, but it's really good. And I haven't even started to mess around with those programmable pins. Oh, blimey, what we'll be able to do with that. We can have Otto moving. We can have 4 videos on there for Bill on 4 OLEDs, NeoPixels, you name it, all of it running simultaneously, and Otto moving around quite happily, not stopping, no blocking. Yeah, this is the way to go.